So let's go back to our friendly flowchart or algorithm for factoring. Let's say we're given a factoring question and we've determined that there is no GCF, or that we factored the GCF out. And then we ask ourselves the question, how many terms are there in the problem? And we say that there are 3 terms. The first thing I would like for you guys to check is always to see if either of these 2 formulas can be used. If you can use these 2 formulas, you don't have to try the AC method or split the term or even go to the crazy quadratic formula. If you can use these formulas, you're done in 15 seconds flat. So these are the 2 formulas again. A squared plus 2ab plus b squared is a plus b the quantity squared. And we can also sometimes rewrite this as just a plus b times a plus b. And if we have a minus sign in the middle, a squared minus 2ab plus b squared, well, that factors to, or equals, a minus b the quantity squared, and we can rewrite this as a minus b times a minus b. So let's say we have this problem, a factoring question, where we have 3 terms, and we can see from the very beginning that we don't have a GCF because there's a number 1 here. Whenever we have a 1 in the problem as a coefficient, we can't have a GCF of anything other than 1 itself, or a negative 1 for that matter. So basically we've tested to see if there is a GCF. There isn't one. Next question we ask ourselves is how many terms there are. Well, there's 3 terms, so we're going to try one of these 2 formulas. Now you'll notice that the application of the formula should be fairly straightforward. Or the choice to even use the formula should be fairly straightforward. If you have to use the plus formula, all signs have to be pluses. The first term must be a perfect square because you have to take the square root of it. The last term must be a perfect square because you have to take the square root of it. Now, if this sign is negative, so let's say in this problem, the sign on the 1 were a negative, we could not use this formula because this formula only works when you have a squared plus 2ab plus b squared. That's it. It does not work if you change this ordering or if you change the organization of the problem. So if you were to make the 4x squared negative, well, then this formula would not work. So the very first formula does indeed work for this problem, and here's how you use it. You take the square root of the first and the last terms. So the square root of 4x squared will be 2x. The square root of 1 will be 1. Remember that the sign in the middle is always the sign in the middle term. So in this case, because my sign is positive, I keep that sign. I keep the sign of the middle term. And then the last thing you have to see is if the middle term matches or not. This one I put a star next to because this is the term, or this is the step that students that tend to get this question wrong always forget. So let's take a look at what's happening. I take the square root of the first term, I get 2x, and this is my a, this is my first term. I take the square root of the second term, I get 1, that's b in my formula. So I have the square root of 4x squared, a, so I put a 2x there. The middle sign stays the same, so if this were a minus, I would put a minus here. Because this is a plus, I'm going to keep it as a plus. And then the square root of 1 goes here. And this is currently my guess. So I put a square parentheses around it and square it. This is purely my guess. And a lot of students will unfortunately leave this problem as it is without checking the middle term. And then half the time you'll be right. The other half you might get it wrong because you never checked the middle term. What I mean by that is the middle term is 2ab, which is 2 times the first term times the last term. So if this is your guess, if you're saying that I think that this factors to this, the 2x only came from the first term, the 1 only came from the last term, and the plus sign came from the plus sign. We never bother to check whether the 4x really fits in here or doesn't. And the way we do that, or the way we check to see if it fits or not, is by just finding what 2ab is. So 2 times the first term is 2x, times the second term is 1. So 2 times 2x times 1 is 4x. This is the same thing as this. And as a result, we can say that 4x squared plus 4x plus 1 is indeed equal to 2x plus 1, the quantity squared. Or, in other words, we can write this again as 2x plus 1 written twice, because that's what the square implies. So here's the mistake that students make, and here's the one that I would like for you to avoid if possible. Do not just write this equals this without checking the middle term. Because now, what happens if I had changed the problem to 4x squared plus 5x plus 1? The square root of the first term would still be 2x. The square root of the last term would still be 1. The sign in the middle is still a plus, so I would still put a plus here. Now, what happens if you don't check the middle term? The middle term, according to this factor, has to be 4x. But if the question had a 5x, then you would be wrong to say that these two would be the factors of the problem with the 5x. Then you actually have to go try something else. So let's see if we take a look at this. We have 9p squared minus 42p plus 49. I look again at my thought process. I have a factoring question that I'm given. I have to check to see if there's a GCF. So 9, 42, and 49, I'll let you figure out that they have nothing else in common. This term does not have a p, so I cannot factor a p out. So there is no GCF. As to how many terms there are 3 terms. And now it's a matter of checking to see, and this should take 5 seconds. The 5 seconds are spent checking to see, can I take the square root of this term? Yes, it's 3p. Can I take the square root of the last term? Yes, it's 7. Do the signs fit one of the formulas? So either all the signs have to be positive, or just the middle one has to be negative. And that is indeed the case here. And this is using the second formula I had up here, which was a squared minus 2ab plus b squared is equal to a minus b, the quantity squared. So our hypothesis is the square root of 9p squared is 3p. The square root of 49 is 7. We keep the sign in the middle, and then we put a square around the whole thing. So this is my guess for the perfect square. This is my guess for the 2 factors. And what I have to do is check to see if my middle term is the same. So the middle term is always 2ab, or 2 times the first times the second. So 2 times the first term is 6p, times the second term is 42p. So 6p times 7 is 42. Oh, my mistake. This should be a p, and this should be a p. Hopefully you can correct it. It's a minor enough mistake to where I'm not going to record the entire video again. So hopefully you guys are paying attention to this. This should not be an a, this should be a p, because the first term is 3p, not 3a. My apologies, sorry about that. So because the middle term has checked out, we can say that this original trinomial that we were given factors to 3p minus 7, the quantity squared, or just 3p minus 7 times 3p minus 7. Let's look at the next problem. So we have to factor 16m squared plus 97m plus 9. Again, we check to see if there is a GCF. I'm going to just say that there isn't so that we can move on, but you should verify that there is no GCF here. We have 3 terms, so I'm going to try to see if I can use one of the formulas. All 3 signs are plus. Can I take the square root of 16m squared? Absolutely, it gives me 4m. Can I take the square root of 9? Sure, it's 3. So my guess for these factors are going to be 4m plus, because the sign in the middle term is a positive, 3, the quantity squared. Now the problem with that is, if you were to leave it as that, you would get the answer wrong, because the check actually fails here. If you were to multiply 2 times a times b, 2 times 4m times 3, you get 24m. Now the middle term does not match. The middle term is actually 97m. And what we needed in order for that to have been the answer, 24m. So what we say is, the check fails, therefore this does not equal this, which was our guess. And that's the case because the middle terms don't match. So here, can we say that this is prime at this stage? Absolutely not. So here is where we have to check other things, or we have to try other things. Just because the formulas do not work does not mean that we can just abandon the problem. Now, what we have to do instead is, if you remember, the standard form of a quadratic equation is ax squared plus bx plus c. So a is always the coefficient, or the number next to the x squared term, or the square term. So the next question you ask after these formulas don't work is, well, if a is 1, if this number had been 1, then you try something called the AC method. And if a is not 1, then we try something called splitting the middle. So in this case, we would need to try other techniques, and the other technique in this particular case would be splitting the middle term for factoring. So just because the formulas don't work does not mean that it's prime. If the formulas don't work in the 5-second check that you're doing, well, then you either try to use the AC method or you try to use splitting the middle term. Let's look at one more, or a couple more. So let's say the question is this factoring problem, 4d squared plus 12dr plus 9r squared. Our guess comes from the radicals, from the square roots. So the square root of 4d squared is 2d. The square root of 9r squared is 3r. The sign in the middle is a positive, so that comes here. And then we put the whole thing inside a square. So this is purely just a guess right now. We have no idea if this does indeed equal this. So what we have to do is check to see the middle term. 2 times the first term times the last term. So if you multiply 2 times 2d, that's 4d, times 3r, is 4d times 3r would be 12dr, and yay, that is indeed our middle term. So since the middle term matches, 12dr is what we got from our guess, and the 12dr is what we have in the original question, we say that the original problem factors into 2d plus 3r, 2d plus 3r, or 2d plus 3r, the quantity squared. Next question. We have to factor 4d squared minus 12dr plus 9r squared. Notice that this is remarkably similar to this problem. 4d squared plus 12dr plus 9r squared. Here we have 4d squared minus 12dr plus 9r squared. So the only sign that changed was this minus. Our approach remains the same, which is to say we're going to take the square root of 4d squared and get 2d, take the square root of 9r squared and get 3r, keep the sign of the middle term, and then put a square around the whole thing. This currently is our guess. We have not checked the middle term. The middle term check always comes from 2ab, or the middle. Now, when I keep saying middle term, I want to make sure you guys understand that this is the middle term that I'm talking about. So if we go back to the problem, 2 times 2d is 4d, times 3r is 12dr, so that's what we have, and that's indeed what we have in the middle. So since the middle term matches, we can say that 4d squared minus 12dr plus 9r squared is the same as 2d minus 3r, the quantity squared, or 2d minus 3r written twice. So the last thing I want to draw your attention to, and hopefully you picked up on this in these last two examples, was when we factor a squared plus 2ab plus b squared versus a squared minus 2ab plus b squared, the first term and the last term of the factors are the same. The squares are the same. The only thing that's different is the sign in the middle. Again, notice the answer to this problem. 2d plus 3r, 2d plus 3r. Here the answers are 2d minus 3r and 2d minus 3r. So the point I'm trying to make is, if you have already solved a problem with one of the signs, so let's say, in fact, we had solved the one with the negative sign. Let's say you have solved this problem already. All you have to do in order to solve the problem with the plus sign is simply change the sign on your answer. So if you solve this problem with a minus sign in the middle and got a minus in the answer, let's say the next question is a plus sign, well then all you have to do is put a plus sign here. You do not have to go through this entire process from scratch if you know these formulas. The formulas allow us to say, hey, if we've solved the problem with the plus already and we got this answer, the problem with the minus has to be the same answer except for the opposite sign in the middle. And that's it. If you have any questions, please, as always, feel free to ask.